Hello and welcome to Lesson 27, and today we're looking at normal sampling and modeling. So yesterday's goal was to be able to work with normal distributions, and today we get to see some of the applications of them. So our goal today is I can explain and apply a normal sampling to a real-world situation. So we're going to take our skills from the previous lesson and now we're going to apply them to today. So we're looking at a lot of statistical studies look at large groups of data. And when you get a large group of data, we either believe or expect the data to be normally distributed. Okay, and when we plot the data out, that's when you make that determination where yes, it's normally distributed, or identify if there's a positive or negative skew, or if it's bimodal. So, assuming normal distributions, the characteristics can be applied to many real-world applications. And I talked about yesterday with manufacturing. We're looking at bolt length. It varies. So we're talking about tolerances in the construction industry. Not all 2x4s are 8 feet long. Okay, for example, not all components are exactly the same in dimensions. There is a bit of a variance between each one. And the same, we can go down the list here and talk about each one and how that varies. But in each case, we can apply that whole normal distribution. And I talked about in the project there the other day, we're talking about probability studies here. And when you can link probability to the normal distribution, then you can do, or you can extend your knowledge and application to the project itself. So I want to show you some of the applications that are out there and that we can apply to our project itself. All right, so 2 examples today to go through. So the first one, we're looking at an investment. So this is economics. This is someone that would be an investor and the process in which a stock or an RSP or whatever is being analyzed. So that should read 15 years. So over the past 15 years, the stock has been followed and charted, and the information is provided here to the right. We want to answer the following questions. So the first part is we need to find the mean and the standard deviation. So you can do this a variety of ways. You can use technology, you can use your spreadsheet, or you can do it by hand. Again, on the test, I will keep it to no more than 15 pieces of data. So I'm going to pause here so I can calculate the standard deviation and mean, and we'll continue from there. Okay, now in this case I use the graphing calculator to determine my values, and if you need help with that, please come see me and I can show you how to use the calculator. You can also use your spreadsheet software. So I found that the mean for this study was 10.6. And I found that my standard deviation was very, very close actually to the mean, but that's just a coincidence, 10.5. So there is my mean and my standard deviation. And that information is needed because in B part now, it says assume a normal distribution. So when I move into B part, I need to make this statement right here. I'm going to assume that all of the variables in this study or this data is normally distributed with a mean of 10.6 and a standard deviation of 10.5, and we need to put that squared in there for the notation. So that statement right there, the assume a normal distribution, okay, we do that in the real world in order to use that z-score chart and make a statistical analysis, and this is what it turns into. So now we can proceed, and we're going to use that z-score chart in order to solve the remainder of these problems. So scrolling down, to determine the probability, the return will be at least 9%. So again, we are looking for the probability that our random variable will be at least 9%. So that means that it's going to be greater than or equal to 9, which translates to a z-score, and that's what we need in order to use that chart. So over to the side here, I need to calculate my z-score, and it's equal to my data point minus the mean over my standard deviation. So 9 minus the 10.6 divided by my standard deviation, which is 10.5. So I'm going to pause for a second to calculate that, and I need to pull up my z-score chart as well. So if you have yours handy, you want to grab it. All right, so I went ahead and I calculated this, and I got negative 0.15. And again, there's no sense for the z-score chart that I'm using. 2 decimal places is plenty. So at least 9%. When you're looking at the term at least, and I want to talk about that for a second, at least 9%, that means that we are going or looking at the right side of the curve. So again, for some of us, it's necessary. I would still do that sketch, that very quick sketch. So I'll do it off to the side here. So here's my sketch, and I know my mean is in the middle, and it's 10.6. So I'm looking at 9, and I want it greater than. So I am looking at the red. Okay. Now remember, when I go to the z-score chart and look up negative 0.15, it's going to give me the area of the blue. So in order to find red, red would equal, and again I'm oversimplifying it, red is equal to 1, because that's the area under curve. Area under curve minus the blue region. 1 minus blue. So for starters, when I return over to finish up my equation, I'm converting my term, or the random variable, x greater than or equal to 9 to z greater than or equal to, so z greater than or equal to negative 0.15. And then this oversimplification helps me figure out, well, I really want, in order to get the area I need, it's got to be 1 minus my blue region, which would be the probability of z being less than negative 0.15. So once I have that, I can now go to my z chart, and I'm looking up negative 0.15. So I'm going to scroll, or you're going to take your eyes and move down. So here's negative 1, negative 0.1, and then I've got 0, 1, 2, and this is the second digit, 0, 1, 2, 3, 4, 5. So there is negative 0.15, and that's 0.4443. So 0.4413. So if I calculate that, 1 minus 0.4413, I get 5587. So therefore, the probability of earning at least 9%, is a 55.9% chance. Okay, so 55.9% chance that this investment is going to yield 9% return. All right. Now, determine the probability that it will be a negative return. So now I'm on to the second part. So the probability that it will result in a negative number. So let's talk about converting that to math language. So if we want negative values, what does that translate into math speak? Well, it means less than, and I can hear everyone shouting out 0. Okay, so you have to be less than 0. So that's what we're looking for. We're looking for the probability that our return, in this case the random variable, will be less than 0. So we go ahead, and what we're really looking for in terms of being able to use a chart is a z-score. And I'll use that formula again. So it's the same formula, same information, except this time our x value is going to be a 0, 10.6 over 10.5. So the corresponding z-score for that, 10.6 divided that by 10.5, is going to be negative 1.01. So we're looking for z-score less than negative 1.01. And the nice thing here, again, as a sketch, this is just to help you visualize what you're looking for. If this is 10.5, here's 0. We want the area less, and that is what the z-score chart will give you. So no changes are required. We can just read off the number and get our final answer. So going back to our z-chart, our z-score chart, I want negative 1.01, and here's the negative 1. So this would be negative 1.00, negative 1.01. So there's the answer there, 1401. Now my memory, that's how long my memory will last for you. 1401. 0.1401. So therefore, probability, the investment has a negative return, is 14%. So there's a 14% chance that you will have a negative return, a 55.9% chance you'll have more than 9%. So when you're looking, or when they're gauging the safety or the how much risk is involved with a particular stock, that's what they're looking at. They're looking at the probabilities. So in this case, I'd say the stock is fairly safe because 55% chance that it's going to yield 9% or greater is a good return, very good return. C part. So C part, determine the probability the investment will have a return greater than 6%. What assumptions are necessary to answer this question? So the first part is just a straight probability, X being greater than 6%. So that translates to a Z-score of X minus X bar over S, so 6 minus 10.6 over 10.5. So doing the calculations there, we find the answer to be negative 0.4381. So we are looking at the probability, our Z-score is greater than negative 0.4381. Remember, Z-scores have to be less than, so from, we again do a quick sketch, this is what we're looking at. Again, we want what's less than, so it's a similar situation to what we had with this sketch right here. We want that value to the right, so we have to take 1 minus the area that we can calculate. And if we go to our Z-score chart, we find that the value, or the corresponding value, is, equal to, from the Z-score chart, 0.3624, which means that our answer then would be 0.6376. So therefore, there is a, let's call it a 63.8% chance. 8% chance it will get at least 6%. And to finish off the question says what assumptions need to be made. Well, the assumptions that need to be made here are, first of all, we're assuming it's a normal distribution. So that's the first one. Assume a normal distribution. And that was stated in the question. And second of all, what else do we need to consider here? Well, in terms of economics, we have to assume that the economic times remain consistent. So economic times remain consistent. Because this prediction, is based on the pattern over the last couple of years. What happens if we run into a recession, for example? That changes our prediction. Not sure on the spelling there, recession. Or if we enter an economic time of boom. What happens if there's an explosion? Then we've underestimated. So there are all factors involved in there in economics. It could be natural disasters could affect it, this particular investment, and environmental change. This could be a technology company that produces a product that's no longer required. There's tons of factors in there, so we're making sure that the economic times remain consistent. So those are the things that when you go to a money analyst or an advisor or a banker, that's what they're doing. They're doing predictions based on probabilities because there is no guarantee in life. Everything's based on assumptions or guesses, and this is one of the processes that are commonly used out there. All right. So if you have any questions, and I'm going to talk to you, I have one more example to get through in this particular lesson, so we'll talk to you in a minute.